Aldrin J. Soriano. I am Reming Cristal Rizalde from 3ECEB, and this is the last part of the activity of our midterm laboratory, which is the activity number 4. So, in this activity, it consists of four problems, and we are tasked to find the value of C flag to fully understand the instruction. So to fully understand the instruction, it will be flashed on the screen. So just like the three activities we first created, so just like the three activities we created a while ago, we'll use the Atmel AVR assembler here. For our project name this as Activity 4. So Activity 4. And for our location, I will use the Activity 4 folder, and then we click Next. And for our debug platform, we will also use AVR simulator as well as the device at Mega 32. And then click Finish. So the code was already given, as I've said a while ago. It has been flashed on the screen also a while ago. So let me just type in the code first. Let me finish typing the code. So there. So here I'm already done with the first problem, and I've already input the code. We are going to proceed to assemble this to check for any errors. So it is still loading. So there, we can now proceed with the debug mode with this assemble and run. So okay, expand the registers. So using the single step, we are going to examine the registers, but first in the loading instruction there are. Okay, wait, let me just use the single step. So there. In the first loading instruction, there are no changes, as well as the second. Okay, there. And then after the add instruction, the sign, the the V, the two complement overflowing overflow flag, as well as the carry flag are turned on. So meaning the addition of R20 and R21 has exceeded the 8 bit of the status register. Then we're going to reset this to examine the registers. If the load are changing, So here, using the single step, so there, as you can see, the load of each register is changing according to its given value. And after the add value, the R20 has changed. And then, so now we are done with the first problem. Let's proceed to the second one. Let me just create new project. No, let me just use this one. So let us just use this. So here, ay, okay, sorry. So it's still flashing on the screen. So let me just change the value. So this is R16. R16 going to be X15. This is going to be 17. And this is 72. And 16, 17. Add R16 and R17. It's not. So there, we're still using the here, our JMP here. And then now, assemble this to check for any errors. So as you can see, there are no error. Let's proceed to assemble and run. So let's examine the C flag after loading and adding the values. So we are going to examine for the C flag as for the instruction using the single step. As you can see, nothing happens. But as we go to the add instruction, this V and N, the negative flag, is turned on. So there. And the C flag here is turned off. This is maybe because of the resulting value after adding the R16 and R17 does not exceed the 8-bit status register. So let us reset this and examine the registers. As you can see, the register 16 and 17 is changing in accordance to their uh, load values, and the add values of R16 and R17 changes R16. So there. Let us now, so after the second problem, let's proceed to the third problem. I will again change the values of the code to save time. So let me just get the value. So this is going to be R25. This is the third problem. And this is going to be F5. And this is going to be R26 and 52. And we're going to add register 25. Okay, wait. Register 25 with register 26 and same. And then assemble to check for any errors. So there are no errors in this code. Let us now proceed to assemble and run. Okay. We're going to check for the flags using the single step and uh, add skipping to the add instruction. We notice that the carry flag is turned on there. So wait, let me just double check. So C flag of this problem has been turned on, so meaning adding R25 and R26 has exceeded the 8-bit register value. So let's reset this to examine the registers. Okay. Then using the single step, you will notice the R25 changes its values according to its load, as well as the R26. And as it reaches to the add instruction, the values of R25 and R26 also changes. So there. Finally, we can now proceed with the last problem. So just like what I did, I will just rewrite the code. So let me just write this code first. Okay. Here is R25. This is going to be E. Then we'll use increment. We're going to use increment here. It's going to be R25 and okay, wait. So here is the code. I will now assemble to verify if there are errors present in this code. And as you can see, there are no errors in this code. We'll now proceed to assemble and run. So there. Checking the flags using the single step. So in our first increment, so LDI, we'll just skip LDI. And as you can see in our first increment, there, the increment instruction, the flags S and N are turned on and the C flag has not changed, meaning it does not exceeded the 8-bit register. So as we go to with the next increment instruction, the zero flag has been turned on, meaning the resulting value of the previous instruction has been equal to 0, which means equal to 1 of our Z flag in the status register. So we'll reset it again to check for the um, LDI. So there. As you can see, R25 changes as the load in accordance to its load value. So that's it. Thank you for watching this video with this midterm